Good morning. We're going to quickly go through some binomial probability distribution. This is what we covered in class on Thursday. So remember, a binomial experiment has n repeated trials, more than one. Each trial has two outcomes, which we call success and failure. And our success is given a probability with p, and our failure is given a probability of q. And the probability of success plus the probability of failure has to add up to 1. The probability of success has to stay the same every time you do your experiment, which means our trials are independent. So this is a binomial experiment because I have more than one time that I'm flipping my coin. There are only two outcomes. The probability of success, which is getting a heads, is always the same, 0.5, and that makes our trials independent. We can make a probability distribution by drawing a tree diagram and then following the outcomes and the branches to come up with the probabilities, our p of x values, or we can make use of our formula that we'll use, and we'll see that in a minute. But today I wanted to specifically go over how to calculate the mean. What's the average number of heads that will show up when I flip a coin twice? Well, if you think about it, you should be able to come up with 1, because if there's a 50-50 shot at getting a heads, you would think, okay, well, half of 2 is 1. Well, the way we get that with our formula is by taking the number of times we do something, the number of trials, times our probability of success. And we can get 1 that way. This is a much nicer formula than the one we used with the general probability. Our standard deviation is also a lot nicer to use than the previous formula that we had. Here we just take the square root of the number of trials times the probability of success times the probability of failure. Now remember, this is what we were having to use prior to learning about this formula. So this standard deviation formula is much nicer, and we'll end up getting 0.7071. Suppose a die is tossed 5 times. What's the probability of getting exactly 3 2s? Why is this a binomial experiment? Well, we have more than one trial. We're tossing our die 5 times. I can either get a 2 or not, or sorry, I can get a 3. Wait, I'm reading this wrong. I can get a 2 or not get a 2. So there's my 2 outcomes. And whether I got a 2 on the first roll doesn't have any effect on what I will get on the next rolls after that. So it's an independent trial, which makes my probability constant every time. So our number of trials is 5. The number of successes I'm being asked about is 3. The probability that I would get a success is 1 out of 6, because there's 6 different numbers that I could get on a die. And so we're going to use our binomial formula rather than trying to set up a tree. And we saw this in class the other day. Now remember, if you're using a scientific calculator, you want to use the PRB menu. If you're using the Casio, I think it was the shift and the divide sign to get you this combination type number. Let's see. We want to find the mean and standard deviation here. So our mean is the number of trials times the probability of success on a trial. That turns out to be 0.83 or 0.833. Turns out our standard deviation is the same thing. That's just by coincidence, but the square root of n times the probability of success times the probability of failure. Let's look at this problem. It came from a different book. According to a U.S. government study, 68% of all children live in homes with 2 married parents. Assuming that's true for all children currently, find the probability that in a random sample of 12, the number who live in a home with 2 married parents is exactly 6. So we're going to set up our formula. 12 is our n value. 6 is the x that they're asking us for. 0.68 is our probability of success. That's p. Q, remember p plus q has to add up to 1. Q is our probability of failure. And here we have our n minus x for our exponent. So we get